Today we're going to walk through the process of building an app that works just as well offline as it does online using IBM MobileFirst and Bluemix. Context is everything when you're building mobile applications. You don't know if the end user is going to be in an office that has great Wi-Fi, if they're going to be driving down the road and have sporadic internet or connectivity, or if they're going to be on top of a mountain and have no connectivity altogether. What we want to do is empower developers to be able to build applications that can handle any one of these scenarios. And we're going to leverage the mobile-first capabilities on top of Bluemix in order to achieve this. This is going to provide us with user authentication, operational analytics, the Cloud and NoSQL database, which has the local and remote data store with synchronization, and it's going to give us a Node.js backend, so if we want to expose this exact same data on a web-based endpoint. The app that we're going to create is going to allow the user to take pictures, and it's going to associate location information, so their lat-long coordinates. It's going to save that in a local data store, and then it's going to use Replication, which is built into the MobileFirst mobile SDK, to automatically save that data up to the remote cloud and data store. Since we're using user authentication, the easiest and most relatable type of user authentication for developers is to actually include a third-party OAuth, kind of like Facebook or Twitter. So we're going to use Facebook in this case, and the first thing I need to do is create a new app for authentication on Facebook. So if we go to developers.facebook.com/apps, we can create a new app ID. So add new app. We want to select the platform that we're targeting, and in this case, I'm going to choose iOS because I'm building a native iOS application. And the app that we're going to create, basing off the template, is called GeoPix. So I want to call this GeoPix-sample. And we just hit Create New Facebook App ID. Facebook's going to ask us a couple of questions. Is this a test version of another app? In this case, no, it's not. I'm creating a new app. If we want to give it a category, you can do that. We're just going to call this communication. Sure, why not? So we're creating the app ID. Facebook is going to give it an app ID, secret key, and we're going to need to take those values, and we're going to use those in the configuration of our native application. Since we're using the MobileFirst SDK, which uses a tool called CocoaPods to download dependencies, we don't have to download and install the Facebook SDK. It's going to pull down those dependencies for us. The things that we do need to pay attention to is our app ID, the app name, and the value here, which is FB, and then the app ID, because we're going to need to put those in our native Xcode project. We also need to specify the bundle identifier. The bundle identifier is the unique ID for your application, which is going to be live in the App Store. This is normally done as a reverse URL notation. So for my Apple account, I'm going to do com.tricedesigns, and then we're going to give it the name of the application. So I'll call it geopix-sample. And once we're ready, we can go ahead and hit next. Facebook will now prompt us with some code that could be included in a native application. Again, because we're leveraging the MobileFirst SDK for Bluemix, we don't need to worry about this. So let me scroll down, and it looks like everything's complete. We're finished. The app has been created. If I go to My Apps, you can see right here we've got GeoPix-sample. Now, this is not available to all users yet because I haven't pushed it live. If you want absolutely anyone on Facebook to be able to log in, you need to be able to push this live. For right now, I'm not worried about that. Now that we've created our app authentication on Facebook, let's go ahead and create and configure the backend infrastructure for our app on Bluemix. Right now, I'm on the Bluemix dashboard, and I want to select Create an App to create a new application. And I'm going to create a new mobile app, and I'm going to choose the iOS 8 target. And this includes the SDK for Node.js, so it's a Node.js server instance, the Cloud and NoSQL database, the push service for iOS 8, which allows you to manage push notifications, and advanced mobile access. The only one of these that we're actually not using in the sample app is push notifications, because we're not driving engagement with push notifications, but you could easily include this also. We'll hit continue, and then we'll be prompted for our app name, and I will call this geopix-sample. You can see if I just do geopix, we get a warning, someone's already using that name. I'm actually using that in a separate instance that I have here. But I'm going to go back and call this geopix sample. When we hit finish, our backend infrastructure will be created. The Bluemix dashboard will let us know that our app has been created, and we can go ahead and start configuring it. The first thing I want to do is specify the bundle ID, and this is going to be that unique identifier for your application. We just use this when we're configuring our Facebook application, so it'll be com.tricedesignz.geopix-sample, and we're going to set this to version 1.0. If you are starting from a brand new Xcode project, you need to follow the instructions here to set up your environment. This uses a framework called CocoaPods to manage dependencies for native applications. I've already configured this in the sample project, and if you haven't downloaded the sample code, you should do so now. You're going to need it to set up your environment and build this entire example off of. And when the steps I'm about to walk through, we'll walk through these exact same steps. So I will hit done. And now our application infrastructure is set up and complete. You can see we've got our Node.js instance, and if we wanted to scale up memory, scale up the number of instances, we would have the option to do that. You can see we've got our advanced mobile access, our cloud at NoSQL DB, and the push notification service. If I jump over to the local file system, I've got my iOS native folder, and in here I've got the app. I could open this up in Xcode, you could see the native project, but because it doesn't have all the dependencies yet, you won't actually be able to run it. So let me jump over to our command prompt. I'll clear this, and you can see right now we are in that exact same folder. So we're in the iOS native folder. And I'm going to run the CocoaPods installer. So just by typing pod install. And this is based on the instructions that were just displayed from Bluemix. And this is going to analyze dependencies, and it's going to download all dependencies for this project so that they are available locally, and you can compile all of the SDK APIs into your application. Okay, now the downloading of dependencies has been complete, and our project has now been configured to include all these so we can use them within our application. So let me jump back over to Finder. And the project that was existing was this geopix.xcode project. When we launch the application now, we want to make sure that we're launching the workspace, because the workspace contains everything inside the pods directory also, which contains all of the third-party APIs and frameworks that are going to be included within our app. So I'm going to go ahead and open this with Xcode. And we can see we've got our app here. And I've already got this configured, but if you're creating your own version of the app, you need to specify a unique bundle identifier. So you could change that here. And now I can go ahead and launch this app. You'll notice here the app's asking for our permission to access our location. I'm going to hit allow. This is based on the lat-lon that's for the simulator. If you were on a real device, it would pull your actual location as long as you've given it permission. What this application, when completed, will allow us to do is take a picture or upload an existing image, save that to the device locally, and then use Replication to take that local data and automatically save it up to the cloud and data store that resides on top of Bluemix. Right now, we haven't integrated any of the MobileFirst or Cloud and APIs, so it's not going to do anything. I mean, I can select an image here, but because we haven't implemented anything, it's, I can see the background changed, but if I come in here to view my local data store, no data exists. So the next thing that we want to do is start integrating some of the MobileFirst APIs. Let me go ahead and kill this. So I'm going to jump back to our Bluemix dashboard, and I want to add that Facebook authentication to our application. So I'm going to go into Advanced Mobile Access. And for my app version for GeoPix sample, which here says allows unauthenticated access to the backend, I'm going to go in and I want to add new authentication. And here's where I will add Facebook authentication. And I need to get the Facebook app ID. So if I come back over to Facebook, I can see here's my GeoPix sample app. I can copy the app ID. We'll paste that right in and save it. Bluemix will provide you step-by-step instructions how to do this. We've already got this code living inside of our project. We just need to go uncomment it and we'll walk through the process. So let's go ahead and do that now. Before we can actually invoke any of the methods that we have here for integrating with the MobileFirst platform with Facebook authentication, we need to configure the application so it can handle the Facebook authentication. And if we come down to supporting files and info.plist, there's a couple values that we need to set. First of all, we need to set the Facebook app ID, and we can paste that because we just copied it from Facebook. We need to set the Facebook app name, and this again is going to be geopix-sample. These values that we're looking at inside of this plist file are actually used by the Facebook SDK. And we need to come down to URL schemes, or URL types, select URL schemes, and then we need to enter the value that we have here, where it's going to be Facebook followed by our app ID, no space in between. So we've now set these three values, and these are required by the Facebook API. Now we can come over to our configuration.h class, and this is just a header file where I've set some essentially global values where we're going to put our Bluemix route, which is the URL to our Bluemix server, the live application out in the wild, and our Bluemix GUID, which is our unique app ID on Bluemix. So if I go back to the browser and we go back to our sample application, and we go back to our GeoPix sample application, we can see our route is right here, geopix-sample.mybluemix.net. So we'll copy that. We need to paste that here. Actually, we need to paste it prefix with the HTTPS. And then we need to get our Bluemix GUID, which if we come back over to Advanced Mobile Access, hit Show Credentials, that's going to be the value for client ID. So we can come over, we can select that, we'll copy that, and then we'll go back to Xcode and we will paste the Bluemix GUID. Now if we come back to our app delegate class, app delegate is essentially the first thing that runs when you're launching a native iOS application. And if we look at application did finish launching with options, that's the first thing that runs. So it's where you want to start setting up your connection with the MobileFirst classes. Because what we're going to do is we're going to add user authentication and instrumentation. So we're going to be able to track the devices that are logging to the app. We're going to set up logging so we can capture any kind of uncaught exceptions. We can capture developer logs. And we're also going to leverage the user authentication that we've been setting up. So the first thing that we do is initialize a session for the MobileFirst classes. So right here we've got IMF client, and we're calling IMF client initialize with backend route, and that uses the route and the GUID that we just configured. So we've set up our configuration to the backend. After we've initialized the session, we're going to set up our logging so we can capture and record. We're going to capture uncaught exceptions, and we're setting the log level, so the log level is trace. So by changing the log level, you can choose the granularity of messages that you want to be captured and sent to the server. So do you want everything sent to the server? Do you just want error messages sent to the server? So you can specify whether you want everything sent to the server or just error messages sent to the server. Once we've set our log level, then we're creating an instance of a logger for this class, and we're going to log a debug message just saying initializing Bluemix client. and then we're going to log a debug, then we're going to log a debug, and then we're going to log a debug message that says initializing Bluemix client. Any debug message that is Any message that you write out using the logger will be available in the console here inside of Xcode if you're debugging it across a USB connection, but these will also be sent up to the Bluemix server. And you can, by default, these will be sent when the app is started or if the log buffer reaches a specific size, but you can manually send these to the server at any point in time by calling IMF logger send. After we've set up our session, we've set up our logging, the last thing to do is initialize Facebook for user authentication. And all that we have to do is add this single line. So we have IMF Facebook authentication handler, which is the MobileFirst Facebook authentication handler, registered with default delegate. And that's going to add all the callbacks, almost everything that's needed to use Facebook as the identity provider for our application. There's just two things that we have to do to turn on authentication with Facebook. The first thing I want to do is come down here to application did become active. This method is invoked whenever the application becomes active on the device. So if it was in the background and goes into foreground, it's going to become active. If it's, you first launch the app from the home screen, it's going to trigger this. And this allows us to track activity monitoring, not only from MobileFirst, but also if you were to look at the Facebook app ID to see the activity on Facebook. And the last thing we need to do is add the callback that's used by Facebook for authentication. So once Facebook authenticates you, it opens your app by associating a specific URL pattern to your application, and this function gets invoked, and we'll use the Facebook API to call the handle open URL method, and that's going to enable us to log into the application and be authenticated. So I will go ahead and run this application again. And let me switch over to this emulator. And now that we have the app up and running, the first thing that it did was actually ask me to log into Facebook so that it could get permission before I'm actually allowed to do anything. So I will enter my Facebook information. And now Facebook is asking me, GeoPix sample will receive the following information from your public profile. It does not let the app post Facebook, so we're not giving the app permission to post to Facebook. We're just using it to provide identity information to our app. And when we hit OK, that's going to redirect us back to our app, and we're now logged in and we have permission. So at this point, we've now got our app up and running. We're using MobileFirst to implement logging, we're using it to do activity tracking, and we're using it for user authentication. Let me jump back over to Google Chrome, and if I come into our advanced mobile access, and if I go into advanced mobile access and then select monitoring, then we're going to be able to start to see some of the analytics that I was talking about, where I can see I've got one active device today, and that's because I just set this up. I could come in and see, the average application views per day. Because I'm not live, I haven't gotten a lot of information. There's not much available left, but I'll be able to see the device. I can see, the average new devices, the total number of devices. I can see logs for these devices. So you can see right here, the debug simulant that I had written out, initializing Bluemix client. You can see that it was from the simulator. My simulator is iOS 8.2. It was a debug message, and I can come in and see a lot of details about this. I could also come in and see information based on the number of authentications over whatever period of time I choose. So I get all of this monitoring and user authentication out of the box by using the MobileFirst application template on Bluemix. So now let me jump back over to Xcode, and let's start integrating the data management aspects of the app. All of the behaviors for the view is managed inside of the view controller class, which we've got right here. There's a header for it and our .m file, which is the implementation of our view controller. And there's all the information about setting up the views, asking for location, displaying the information. And let me scroll down to the bottom, because what I want to show you is image picker controller did finish picking media with info. This is going to be called regardless of whether we're taking a picture with the camera or we're just accessing an image from that's already captured locally on the device. And you'll notice right here that sends the data to our data manager class, which is a singleton instance, so that means there's only one instance ever in memory, to the save image function. So let's now go over to our data manager class and let's set up everything that we need for data storage using the MobileFirst classes. I've already got this commented out in specific chunks, and that way we can walk through each piece of the process. The first thing I want to do is set up local storage on the device. So it's a local data store. Right here, I'm initializing an instance of IMF Data Manager, which is the MobileFirst Data Manager class. This is going to manage our data stores within the app. And then the next thing I'm going to do is create a data store instance. So I'm going to use that data manager that we just created, create a local store, and we're going to give it the name GeoPix. If there was an error, then we're just going to do a debug statement saying there's an error created in the local data store. But most cases, this shouldn't happen. And if the data store already exists, then it's going to give us a reference to the data store. It's not going to overwrite or delete any data. Now that we've got our local data store, we need to write data to that data store. So we can jump down to our save image function, which we have right here. So I'm going to uncomment the code within our save image function. And this is basically broken up into 3 parts. The first thing that happens is a document is created. A document is a piece of data that's going to be saved into the Cloud and NoSQL data store. The local store is a object store locally on the device, which is functionally compatible to the Cloud and NoSQL data store. And the best way to think of these is like a just generic object, like a JSON object that is a key value store where you can have keys and you assign a value to that. You can configure this to serialize strongly typed objects and use the MobileFirst SDK to serialize those into the strongly typed objects for you. But for simplicity, I'm keeping this as generic objects. So what we do is we create a mutable document revision, which means it's a document revision that can be changed. And we're going to assign the body of that document revision to the data that we want to save. So we've got our date, we've got our location information, so we've got our latitude, our longitude, our altitude, and course. And then I'm assigning a type to this, which is just a string value that I'm going to use later when searching of com.geopix.entry, because it's an entry into the system. So we've created our revision, and the next thing that we need to do is take that image data and save it as an attachment to our document revision. And the reason that these are called revisions is that you can have multiple revisions for a document, so there can be history tracked for all the documents that are in the data store. The first thing I do is create a name for the image based upon the current date. So I assign the time interval since 1970 into a file name, and this is going to be saved as a JPEG. And then we create our temporary directory. We get the full path to our temporary directory and the image name. And then we're going to take a JPEG representation of that image and write it to a file. Once we've written that data to a file, we're going to create a unsaved file attachment using CDT unsaved file attachment class. That's a Cloud and unsaved file attachment. And we're going to give it the path to the image that we just saved with the name of the image name up here that we just created. And we're going to specify our type is image/JPEG, which is essentially like a MIME type. And that's because we are saving a JPEG representation of that. Once we've created that file, we've created the unsaved file attachment, we need to assign that in the attachments on the document revision. So you can see right here our revision.attachments, and we're giving it, this is a shorthand notation for an object. So we're going to say for the key, which is our image name, we're giving it the value of the attachment that we just created. And this is a logical representation. So it's an object that has the metadata, which we defined up here, and it now has a JPEG file attachment attached to it. And once we have this information, we've assigned it, we just need to save it. So on our data store, we're going to use the save method, and that's going to save it locally. So you can see we've got data store save. We're going to pass in our revision. And then once that save is completed, we're going to see if there's an error. If there's an error, we handle it accordingly. And if it's saved successfully, then we're just going to write out a debug message saying it's been saved successfully. So now I will save this and launch it. And okay, we're now on the iOS simulator. So now if I go in and I select an image, we're going to choose, our image has been selected, it's been saved locally. You can see right here in our debug logs, document created. So we can see the information here that was written out that it has been created. And if we look at our debug message right here, we can see that it says document created, and we pass in a reference to the object for the last value, and you can see the document was created. It's a CDD document revision, and it lives at this memory address right now. So I'm going to go ahead and stop the debugger, and now let's scroll down all the way down to our get local data method, because once we've saved data locally, we want to be able to retrieve that data locally. So I'm going to uncomment our code right here. And we can see that in the get local data method, we're going to, once we have that data from the local data store, we're going to call the completion handler, which is basically a code block that gets passed into this. This is being called from our view controller class. And when we're searching the data store, the first thing we do is create a query predicate, where you can see we're going to pull back all data with the type as com.geopix.entry. And this matches the metadata that I had mentioned earlier. Once we have our query predicate, we need to create a query object, and we're going to use a CDT Cloudant query class, which is just a query for the Cloudant data store. And we're going to initialize it with the query predicate that we just created. And this is basically just telling it from the data store, create a query, return all objects with the type equals com.geopix.entry. And on our data store, and this is the local data store that we just created, we're going to call perform query, and when that query is complete, it'll invoke the completion handler. And if I jump back to our photos grid view controller, and this is where it's actually saying, give me the local data because I want to display it. You can see right here we have data manager, shared instance, get local data, and that's going to return to us in our completion handler. That's going to give us an array of results and an error if there's an error. So if an error happens, you need to handle it accordingly. And what I'm going to do is I'm going to take that array of results, I'm going to save it into a local variable, and then in a data grid that I have, I'm just going to call reload data. So let me go back to our application now that we've uncommented the pieces for accessing the locally stored information. And I'm going to click on the button up here in the top right. And you can see we now are able to see our locally stored data. So we've got one image, nice beautiful waterfall. Let me go ahead and upload another image, and we'll choose the field and the flowers. And if I come back here, you can see we now have 2 images that have been saved locally. This data has only been saved locally. We have not implemented replication, so it is not being pushed up to the cloud yet. So if I come back over to Xcode, let's turn on replication so that our changes are automatically saved into the cloud. Once we have replication in place, we only have to worry about saving locally, and replication is a fire and forget process that will automatically push data up to the cloud. So in my data manager class, again, I'm going to scroll back up to the top. And inside of our init method, which is the first method that gets invoked for our data manager once it's created, we're going to next create a remote data store. So with this uncommented, you can see self.manager, we're going to create a remote store. When we created the local store earlier, we just used self.manager local store, we gave it the name. We're going to call remote store, we're going to give it the same name, and we have a completion handler, so once it's been created remotely, this will be invoked. So we'll be able to see, was there an error? If so, handle it accordingly. If not, we need to assign user permissions, and this is very important, otherwise you will run into problems trying to save or access data to the remote data store up on the Cloudant server. So we just need to set user permissions to this value, db_access_group members, for the data store named GeoPix. Once we've assigned user permissions, and again, I'll say this is important, you need to do this, otherwise you're not going to have permission to read and write to the local data store if you don't set permissions on the manager. Now we need to trigger the replication process. And so a little bit further down in our init method, let me uncomment self.replicate. And if I jump to our replicate function, this is where we set up replication. It will read the copy of the local data and automatically push that up to the cloud. So I'll uncomment this piece, and replication can be set up so it can be either one way, either push or pull, or it can be two way. So it will automatically push changes to the remote data store and automatically pull changes from the remote data store. And you can set that so it pulls from the entire data store, but if you have a really big database that gets unyieldy, or you can have it so it pulls data from a view of the Cloudant data store. So it's not pulling everything, only the view that you've defined. The first thing we need to do is set up a push replication instance. So we're going to create a push replication instance using our data manager class and push replication for store. We're going to give it the same GeoPix name because that's the name of our data store. And then we're going to create a replicator instance. And we're going to use that same data manager class, use replicator factory, and give it one-way push from the push replication instance that we just created. This might sound a little bit confusing, but this is what you need to do to set it up to push data from the local data store to the remote data store. If you run into an error, you handle that accordingly. If we scroll down a little bit further, when we want to start replication, all that we have to do is call the start with error method on the replicator, which we just created right up here. We'll call start with error, and this will start the replication process. If there's an error, you'll be able to see that, you'll be able to handle it accordingly. But replication is a fire and forget process. Once replication is started, anytime you make changes to the local database, they will automatically be replicated up to the remote database without you having to make any additional changes to code. So if I take another picture, and as soon as I save that to the local store, that'll automatically trigger the replication process, and that will automatically push the changes up to the remote server. The last piece that I want to do here for replication is I want to assign a replicator delegate. The replicator delegate is a protocol, which if you're not familiar with protocol, in Java terms, this would be an interface, which is a set of methods that can be implemented and enables polymorphism in the design of your software. So right here, I'm setting the delegate for my replicator, and again, this is a replicator we just created right here, to self, which means it's this class, where if I scroll down and I uncomment this code block, this is where I implement the methods for the CDT replicator delegate protocol. These methods are going to be triggered if the replicator changed state, so if replication started or stopped. When progress changes, so let's say I'm trying to replicate 5 entries, I can see I'm on entry 1, entry 2, entry 3, entry 4, entry 5. I can see if an error occurred, and I can see when replication is complete. And the way that I have this set up is it's using iOS notifications to communicate back with our view controller class to let it know when the replication state has changed. So if I run this again, you'll see automatically up here in the top left corner, replication started, replication 0, 2, 1, and 2, replication complete. And That just took these two images that were automatically saved locally and pushed them up to the remote data store, so up in the cloud. Now let's jump back to Bluemix and then go to our Cloud at NoSQL DB. And then go to our Cloud dashboard. Here you can see our database. So we've got GeoPix here, and I can come into all documents and I can see the documents that have been saved. Right here, I've got the latitude, the longitude, which is our location. We've got our timestamp, and we can see that there is an attachment. I can come up to view attachments, and I can actually see the attachments. So we've got our waterfall here, and if I jump back and we look at the second document, I can come in and we can see our flower. So our data that we've captured on the device, the location as well as the image attachments, have been saved in the local data store, so they're accessible on the device, and they've also, through replication, been saved up to the remote data store. So let me go ahead and we'll close this. We can go ahead and close out our Cloud dashboard. And now we want to expose this data to the Node.js server, because Node.js is the other part of our application. So I'm coming back to the command prompt, and let me go up a directory, and I've got a directory called Node.js. Oops. Okay, let me go ahead and clear the console here, and we'll do it, and we'll list the directory contents. In here is my Node.js application that I want to deploy to Node.js on Bluemix. If I actually go ahead and jump over to my code editor, I can come in and I can view my Node.js code. I can make changes if I want. We can see everything. You can see where I'm actually accessing the Cloud API. So it's pulling the login credentials actually from the Bluemix environment. If you are not using Bluemix and you're running it on a local Node.js server, you'd have to put in your Bluemix username and password and your Cloud URL in order to get it to run locally. And as it is, if you've downloaded the sample code, you don't need to make any changes to get this up and running. It uses the Jade template engine to take the data from Cloud and turn that into HTML. The app also uses the leaflet mapping engine plus OpenStreetMap data to visualize the images that have been captured on a map. The one thing that you will have to do in order to deploy this on your own Bluemix account is go into Manifest, and you need to change the services here. The services, the host name, and the app name to match the name of your app as you've given it on Bluemix. Once you are sure that these match, and make sure that they match, because if they don't, that can cause problems with your Bluemix app configuration. Once you're sure that these match, you can use the Cloud Foundry command line API to push this code up to the server and deploy it to the Node.js server. So if you weren't already logged in, you would call cf login. It's going to ask you for your email, your password. Oh, apparently I mistyped it. And then it's going to ask you to select your space on Bluemix. So what's your organization? Do my personal organization. And then I'm going to select my dev space. And now we're logged in. So when I push code, it's going to be pushed to this space on Bluemix. And I'm already in the directory, the Node.js directory, which contains my app for app.js and also my manifest. So we'll just call cf push. This will upload your code to Bluemix, bind the services to the app, import any missing dependencies that it needs, restart the app, and then when it's all completed, you'll be able to see the state of your server right here. We can see I've got one server up and running. It's been running since 30 seconds ago. It's at 0% CPU. We can see the memory and the disk size. And if I actually come back over to the browser and we go to geopix-sample, here is our app that's actually running on Bluemix. And the location here was pulled from the iOS simulator, so it thinks I'm in the San Francisco area. But you can see we've got the images. We've got two images that we just uploaded, so I can view it on a map, or I can view it on a list. And this is all powered from the Bluemix infrastructure.